All right, so now we're putting this all together. We're going to be creating graphs of rational functions and kind of pulling apart all of their different aspects as we go. So as you are graphing this, if you're graphing this on pencil and paper, anything that's asked for, so if you're asked to find a vertical asymptote, if you're asked to find a horizontal asymptote, make sure that that visually appears in your graph as well. So we're going to identify all of these components listed. Step 1, vertical asymptote. To find this, we set the denominator equal to 0. Remember that your vertical asymptote is in the form x equals some number. Step 2, find your horizontal asymptote. We find this by comparing the degree of the numerator to the degree of the denominator. Your equation is always in the form y equals some number. And all asymptotes are drawn on a graph using a dashed line to represent that asymptote. Step 3, find the y-intercept if there is one. You can identify this visually on the graph, but algebraically the way to find this is to evaluate the function at 0. So if you find f of 0, whatever that function value is, that's your y-intercept. Step 4, find the x-intercepts if there are any by setting y equal to 0 and then solving for x. Again, you could identify these possibly looking at the graph, but the algebraic way to find these is to set your function f of x equal to 0 and then solve for x. And these will give you your y-intercepts if they exist. Then step 5, start on the left side of the graph and use your graphing calculator to guide you in the sketch of the graph. I would recommend using your trace function. My pen is off. So using your trace function just to identify additional points. And then step 6, check if the function is even, odd, or neither to determine symmetry. So remember, we've done this in previous sections. So this is where you first find f of negative x. So first find f of negative x, and then you're going to compare that f of negative x to your original function. So if f of negative x is equal to your original function f of x, you have an even function, which means you have y-axis symmetry. If f of negative x is equal to the negative of f of x, then you have an odd function with origin symmetry. Usually, the first case, the even functions are a little bit easier to spot because f of negative x will just give you back your original function. Especially with rational functions, the odd functions can be a little bit trickier to spot. So I just want to point out, and these won't necessarily be odd, but just if you have like f of x equals, I don't know, x squared minus 7 over x plus 5, let's say. Okay, and I don't know if that's even or odd or whatever, but I just want to show you what negative f of x would equal. So negative f of x, you could either distribute that negative sign through the numerator, so negative x squared minus 7, and then leave the denominator as is. So distributing that negative sign up top, this would give you negative x squared plus 7, whole thing over x plus 5. So that would be one way to outline negative f of x. Or for negative f of x, you could put that negative sign in the denominator but leave the numerator alone. So x squared minus 7 divided by negative x plus 5, which would give you x squared minus 7 over negative x. I don't know why I can't write down there. Negative x minus 5. So that's also negative f of x. And actually a third way to write negative f of x could also appear as just a negative out in front of the entire fraction and then leave everything else the same. So that's yet a third way to write negative f of x. So I just want to point that out because sometimes it's a little bit trickier to spot these odd functions. So I just want to mention that up front. Okay, and then step 7, just mentioning to plot additional points between and beyond each x-intercept and vertical asymptote. So we'll get the hang of that as we go. All right, so number 6, determine steps 1 through 4 for the given function, and then we'll also determine the symmetry and plot additional points. All right, so we're given the function f of x equals 3x plus 6 over x plus 1. Let's go ahead and pull that up in our graphing calculator to start. So y equals, and I'm going to put parentheses, 3x plus 6 around the numerator, and then x plus 1 around the denominator. And take a look at my graph. All right, so I'm using my graphing calculator as just kind of a crutch, a little bit of a help, but I'm not going to totally rely on it. So I'm going to algebraically find all this stuff and then verify it with my graphing calculator. So what you're calculating on paper should match what you're seeing on your calculator. All right, step 1, vertical asymptote. I'm going to take the denominator, x plus 1, set it equal to 0. So that should give me the vertical asymptote, x equals -1. So using my trace function, let's see, my function at 0 is 0.6. My function at -2 is 0. My function at -1, overflow error doesn't exist. That's because that's my vertical asymptote. So that's looking good so far. And I can go ahead and plot these as I calculate them. So my vertical asymptote at x equals -1, there's my vertical dashed line. All right, horizontal asymptote, degree 1 in the numerator, degree 1 in the denominator. So y equals 3 over 1, which is just a 3. I'm just going to write 3 there. So y equals 3 would be my horizontal asymptote. And looking at my graph, I can see that as I go to the extreme right or to the extreme left, it does look like the graph is kind of settling around 3, so visually that corroborates what I just found. So y equals 3, I'll go ahead and plot that. So here's my horizontal asymptote at y equals 3, dashed line. All right, so next up, step 3, find the y-intercept. So I can find this algebraically by evaluating f of 0. So this would be 3 times 0 plus 6 over 0 plus 1. So the zeros are going to 0 out. 6 over 1 gives me 6. So I'm calculating that my y-intercept should be 0, 6. Let's double check this using the trace function. If I type in 0 for x, that does give me the y value of 6. So I'll go ahead and plot 0, 6 as my y-intercept. And then find the x-intercept or intercepts. I can find this by taking my function, 3x plus 6 over x plus 1, and set the entire thing equal to 0. So as long as my denominator doesn't equal 0, notice that really what I'm focusing on here is, does the numerator equal 0? Because 0 divided by 1 is 0, 0 divided by 10 million is 0, 0 divided by 5 is 0. As long as the numerator is 0, it doesn't really matter what the denominator is, as long as it's not also a 0. All right, so 3x plus 6 equals 0. Subtract 6 from both sides. Divide both sides by 3. Gives me x equals -2. So this should give me an x-intercept of -2, 0. Let's verify this on my graphing calculator. Trace, -2, and for x does give me a 0 for y. So -2, 0. There's my x-intercept. Okay. All right, so far we're looking pretty good. I do want to fill this in a bit more, and I can see that, I'll erase this in just a moment, but there's no activity on my graph down here. There's no activity on my graph up here. So I'm just filling in the top right and the bottom left. So I might want to crank out a few additional points just to kind of complete my graph a little bit more. So let me see, I'll go ahead and create a little XY table here. So out on the left, I might do like, I don't know, just a couple to fill in, -6, -3. I'll use the trace function to crank these out. And then between my intercept and my vertical asymptote, maybe I'll put in a -1.5. Over on the right, between my vertical asymptote and my y-intercept, maybe I'll put in a -0.5. And then to the right, maybe I'll do +1 and I don't know, positive 5, let's say. I'm just kind of making stuff up just to kind of identify a few points where I can fill in and just help me shape the sketch of this function here. Oh, and sorry, before I do that, I'm jumping ahead because I totally forgot about the symmetry. So let me do that step first. Although looking at the graphing calculator, I'm anticipating that we're going to not have any symmetry. So it looks like there's none, but let's go ahead and verify this algebraically. So f of negative x, looking at our original function, would equal 3 times negative x plus 6 over negative x plus 1. So this would simplify to negative 3x plus 6 over negative x plus 1. So that's my f of negative x. So it doesn't equal f of x, right? What I'm looking at, negative 3x plus 6 over negative x plus 1, doesn't equal my original function, okay? So it's definitely not equal to f of x, so I don't have y-axis symmetry. It's not an even function. But do I have this equal to negative f of x? So just as a reminder, negative f of x could equal a negative distributed through my numerator, which would be negative 3x minus 6, and then the denominator stays the same over x plus 1, or negative f of x could equal 3x plus 6, nothing changed in the numerator, over negative x minus 1, that minus sign distributed in the denominator. I don't have either case. When I found f of negative x, I got negative 3x plus 6 over negative x plus 1. So it doesn't match this guy, doesn't match this guy. So this also doesn't equal negative f of x. So it's not even or odd, there's no symmetry. Okay, so now let's go ahead and use the trace function to crank out these additional points. And when I'm writing these, I'm just going to write the decimal approximation. I think sometimes different homework systems will ask you to calculate the fractions. If it's a pencil and paper test, I don't care about the fraction values, but I'll show you how to quantify those if you need to. So trace, if I type in negative 6, this gives me a y value of 2.4, so about 2.5. Okay, so for me, I just need enough to eyeball. So negative 6 and then 2.4, that's a little shy of 2.5, so that would be maybe right about there. For the function value as an exact fraction, f of negative 6, my function is 3x plus 6 over x plus 1. So 3 negative 6 plus 6 over negative 6 plus 1. So this would be negative 18 plus 6 over negative 5, which gives me negative 12 over negative 5. So you could also say that this equals, 12 fifths. For me, on a pencil and paper test, 2.4 is fine. If the homework system asked you for a fraction, you would just evaluate it in the function and calculate that and simplify and reduce. So going forward, I'm just going to write the decimals, but you might be asked for the fractions in the homework system. All right, using trace, I'm going to input x equals negative 3. X equals negative 3. And this gives me y equals negative 5, which is a fraction, would be 3 halves. So negative 3, and then, it's positive 1.5. I wrote a negative there, my bad. Ooh, and I erased that whole thing. Ooh, positive 1.5. So negative 3, and then positive 1.5, halfway there. And by the way, as I was starting to graph it, I was second guessing myself because negative 3 and negative 1.5 would be down here, but that wouldn't match up with the intercept. So if you're drawing anything weird, that's a warning sign that maybe you screwed up somewhere, like I just did. Okay, negative 1.5 for x gives me a y value of negative 3. So negative 1.5, and then negative 3 down there. So we can go ahead and skate along these asymptotes. Sorry, that's so wiggly. Okay, so we're just skating along the vertical and horizontal asymptotes there. And then going to that upper right-hand corner of our graph, negative 0.5 in for x gives me a y value of 9. So negative 0.5, 9 would be about here. So I've got that point along my vertical asymptote. And then if I enter 1, oops, sorry, my calculator's freezing. All right, well, so let's do this by hand. So if I enter f of 1, this would be 3 times 1 plus 6 over 1 plus 1, which gives me 3 plus 6, which is 9, over 2, equal to 4.5. So 9 halves, which should be 4.5. So 1 and then 4.5 is right there. And then f of 5, because my calculator is freezing on me, f of 5 would be 3 times 5 plus 6 over 5 plus 1, which gives me 15 plus 6, so 21 over 6. Top and bottom are divisible by 3. They both have a common factor of 3. So this would be 7 over 2, which is 3.5. All right, so 5 and then 3.5 is right there. All right, so again, filling in the sketch so that it skates along those asymptotes. Make sure you don't cross, especially that vertical asymptote, because you're never allowed to cross. All right, so that would be my final answer for number 6. I graphed the function. I identified a number of points. I included the vertical asymptote, the horizontal asymptote with dashed lines. The y-intercept and the x-intercept are clearly labeled. I don't see any symmetry, but I evaluated f of negative x to find out if there was any. And then I'm plotting additional points between and beyond each x-intercept and vertical asymptote. So just additional points on either side of your asymptote and your intercept, just to fill in the gaps and create that overall shape of your graph.